Hey Titans, it's Mr. Spilker here, and today we are going to go over the notes for Chapter 2, Section 6, Adding and Subtracting Expressions. So go ahead and put the heading on your notes, Chapter 2, Section 6, Adding and Subtracting Expressions. Alright, we have 4 definitions for today, and I know you're looking at these and thinking, oh geez, that's a lot to write. You do need to put these into your notes. I will try to paraphrase them a little bit verbally here, and I'll try to underline some key points. The first definition is a term. A term is a number, a variable, or a product or quotient of numbers and variables. So when you think of a term, it's either going to be a number or a variable or a combination of both by multiplication or by division. Most likely, folks, it's going to be by multiplication. So it's a number or a variable, or both, and it's normally held together by multiplication. A coefficient. A coefficient is simply the number out front of a term. The number out in front of a term. Everybody got that? The number out in front is the coefficient. So if I gave you the term 3x, 3 is the coefficient. If I gave you the term 5y squared, 5 is the coefficient. The coefficient is the number out front. Like terms, this is a phrase you're going to hear us use throughout the year. Like terms are two terms that contain the exact same variable. It must be the exact same variable. So as you can see below with the examples, 4xy squared and 6y squared x are like terms because they have the same variable, an x and y squared. 2xy and 3x squared y are not like terms. The one on the left has xy. The one on the right has x squared y. So like terms are two terms that contain the same exact variable. Simplified. We're going to ask you to simplify things in this section, just as we have previously also in a couple sections. When it says to simplify, what it means is to go ahead and take all the like terms and combine them and get rid of all the parentheses. So something is simplified when all like terms have been combined and all parentheses have been removed. Those are your 4 definitions for tonight. So if you're done writing them, we'll go ahead and move on. If not, please push pause at this time and finish writing these. Alright, now that we got our definitions down, let's jump right into the material. Now this section is adding and subtracting expressions. Before we get into the addition and subtraction of expressions, let's go ahead and just do some combining like terms review. This combine like terms review is something that was done in your previous math classes, but we want to brush up on it again here. So if you would go ahead with me and get these examples down in your notes, they'll be fairly quick here. We'll go through combining like terms. 2x plus 3x. What is 2x plus 3x? 2x plus 3x is 5x. Whenever you're adding and subtracting like terms, you add or subtract the coefficient, you leave the variable the same. The big mistake I get on that one is I get students that want to say, oh, 5x squared. No, the variable stays the same, you add and subtract the coefficient. 4x plus 2y, what do you think that one is? 4x plus 2y. Can't simplify it. 4x and 2y are not like terms, so therefore we cannot combine them by addition and subtraction. So 4x plus 2y is just simply 4x plus 2y. 8x minus 3x. 8x minus 3x is 5x. 8 minus 3 is 5. The variable stays the same. 3x plus 3y minus 7x. We have 2 like terms here, 3x and minus 7x. So if I take 3x minus 7x, I would go ahead and keep change, and that would leave me with negative 4x. And then that 3y I can't combine with anything, so it's still on the end there. Negative 4x plus 3y. My next example, x plus 4x. I chose this example because students say, well, x plus 4x would just be 4x. No. If there is not a coefficient, can you guys guess what number's out front? 1. So what is 1x plus 4x? You guessed it, 5x. Good work. The next one, we have xy plus 3xy. Remember, if there's no number out front, we assume there's a 1 there. So what is 1xy plus 3xy? 4xy. So the constant theme of combining like terms is that you add or subtract the coefficient, variable stays the same. So you add or subtract the number out front, the variable stays the same. So 8x plus 3x would be 11x. 8 plus 3 is 11. The variable stays the same. That's a quick review of combining like terms. These are good examples to have down in your notes. Pause the video at this time if needed to finish copying them. Now we will get into another example, and this example is adding and subtracting expressions. This is really the main focus of this lesson. So here we have 5a plus 7b plus 7a minus 12b. Now we categorize these problems by what operation is occurring between the two polynomials. So I call this an addition problem. Middle is, sorry about that, it switched slides there. So we call this an addition problem because it has an addition problem in the middle, or an addition sign in the middle. So now we can go ahead and add these two expressions. Now, I always tell students to go through and get rid of subtraction first. So you see that minus 12b? We're going to change that. We're going to go ahead and keep change there. And we're going to make that become plus negative 12b. Now, once you've made everything in the problem become addition, it's really easy because in addition, order doesn't matter. So I can go ahead and take 5a and 7a, and as you can see down here, I can combine those. 5a and 7a make 12a. And then since everything's addition, I can rearrange this so that my b's are together. And a 7b and a negative 12b, when combined, give me a negative 5b. So to simplify that, it's 12a plus a negative 5b. Students, change everything to addition. Once you change everything to addition, then you can go ahead and rearrange it and regroup it based on the associative and commutative properties. When you do that, you just simply combine like terms. I always tell students these are high V problems. I tell students these are high V problems because it's just like they're working in the produce department at high V. They have a mess on their hands. It's the end of a busy day at the store. They have to go ahead and put things back in place. So in a problem like this, you have to take the 5 apples and the 7 apples and put them together. And you got to take the 7 bananas and the 12 bananas and put those together. So that's kind of the gist of this problem. Let's look at another example. All right, let's go look at another example. This is a subtraction example. And out of the whole lesson, this seems to be the most challenging part for students. So make sure you lock in here. We need a level 10 concentration. Lock in. Ladies and gentlemen, we have 15x plus 8 minus 9x plus 4. As I said, we call this a subtraction problem because what is occurring between our two parentheses there? Subtraction. Now, whenever we see subtraction, we've taught you to keep, change. Now, in this case, we are subtracting that entire second set of parentheses. So the way the keep, change works is we must change that entire second set. So the first set of terms there, we keep them. We change subtraction to addition. And then we change that entire second set of parentheses. So 9x becomes negative 9x. 4 becomes negative 4. Now, as you can see, everything in the problem is addition. That's what we want. We want everything to be addition because that allows us to go ahead and regroup and reorder however we please. So now I can take my x's and put them together. I can take my constants, my numbers, put those together. And then I can simplify and I have my final answer. So whenever you see subtraction, keep, change. If you change, this is a key point right here. If you change a subtraction sign that sits directly outside a set of parentheses, everything in that set of parentheses must change to its opposite. 9x became negative 9x, 4 became negative 4. Make sure you pause the video here and have this example down. All right, final example of the night. Go ahead and write down this example here. And this is I don't know why it says add there. This is actually a subtraction example. So last example of the night here. After this example, I'll probably go do a bunch of curls and biceps and just continue to work on my outrageous strength. Let's go ahead and look at this problem. It's 5a plus 7b minus 7a minus 12b. So in this situation, I have subtraction. So I'm going to keep, change. So my subtraction is going to become addition. 7a becomes negative 7a, and minus 12b becomes its opposite, plus 12b. Now I can go ahead and take 5a and negative 7a, group those two together, and make negative 2a. And I can take 7b and 12b and group those two together and make 19b. All right, Titans, that's the lesson for tonight. Feel free to pause, rewind, do whatever you need with the video here. I got a Google form question below if you would go ahead and fill that out for me. Otherwise, thank you for listening. Hopefully you enjoyed it. Good luck, Titans.
Made with Doodlecast Pro.